Hi, everyone. This is Nick Jacobs, your intermediate algebra instructor here at Yavapai College. Today, I'm going to go through section 7.4, adding and subtracting with unlike denominators. So we did some multiplication and division, which do not require a common denominator, right? And then we added and subtracted rational expressions with like denominators, and today we're going to do unlike denominators. So let's get started. So the first thing that we kind of have to review here is finding least common multiples. We did a little bit of this with factoring earlier. Specifically, well, I guess we found the greatest common factor. So least common multiple is a little bit different. So we're going to review that. Then we're going to review some fractions with unlike denominators. And then we're going to get into the adding and subtracting rational expressions. I think I also took out the application problems for this section like I did for 7.3. So we might get into some of those later in the chapter. So really, the first thing that we have to review is how to find the least common multiple. So basically, the least common multiple of two or more polynomials can be found by factoring each polynomial. Then we would list each factor the greatest number of times it occurs in each factorization. And then we're going to find the product of this list of factors, and that result is the least common multiple. So remember, least common multiple is different than greatest common factor. So if I make up an example here, greatest common factor versus least common multiple, okay? And let's say the numbers are, let's say there's 6 and 9, and I'm trying to find the greatest common factor and the least common multiple. Well, the greatest common factor of 6 and 9 is going to be 3, okay? Because it's the basically the greatest number that you can factor out from those, okay? Actually, let me put this here. So 6 and 9, let's put that down there. And I'll do another example. The least common multiple of those, the least common multiple is actually going to be 18, okay? Because it's the first multiple that has a common multiple. So, you know, if you think of multiples of 6, 12, 18, okay, 9 would be 9 and then 18. Another trick would be to take 9 and multiply it by 2 to get 18, because we know 6 doesn't go into 9, so we have to go to the next biggest multiple of 9, which is 18, and 6 does go into 18. Well, let's do another example. Let's say we're talking about 12 and 20, okay? What's the greatest common factor of those? Well, the greatest common factor of those is going to be 4. And the least common multiple is actually going to be 60. So, and we're going to go through some more examples of that. Okay, so finding the least common multiple of each. So we have to find the least common multiple of each pair of expressions, okay? And again, we're practicing this in order to be able to add and subtract rational expressions with unlike denominators. Okay, so if I had a denominator of 6x and a denominator of 9x to the 4th, we would need to find the least common multiple of those in order to be able to add or subtract them. So the first step is to factor each polynomial completely. And what I mean by that is I want to put this in a product of primes. So I want to make 6 into 2 prime numbers, right? Prime numbers only multiply by 1 in itself. So 6, instead of 6 times x, we're going to write 3 times 2 times x. So now 3 and 2 are both prime numbers. And I have that x there. And then 9 is going to factor into 3 times x times x times x times x. Okay, so it's all factored out. Now the next step is to list each common factor the greatest number of times. Okay, so if I'm listing those, what's the greatest number of times 3 occurs in this? Well, 3 occurs twice in 9x to the 4th. So that's the greatest number of times 3 occurs. What's the greatest number of times 2 occurs? Well, it's just 2, or sorry, it's once, so it would just be a 2, okay? Even though 9x to the 4th doesn't have a 2, we still have to include it. And what's the greatest number of times x occurs in either of these? Well, it's 4 times. So So I'm going to write all those x's out. You generally don't have to do that. Another trick would just be, oh, well, what is your greatest power of x? Well, it's x to the fourth. So you know that in your LCM is going to be an x to the fourth. And then from there, it's just figuring out what's the LCM of 6 and 9. And we know that that would be 18. And we had that in the last example on the last slide. So then the final step is to actually say what the LCM is. And all we would do for that is just multiply all of this together. What we did in step 2. So 3 times 3 times 2 is 18. And then we have the x to the fourth. Okay. And again, I already told you that trick for variables. It would be, you know, the biggest power of a variable, x to the fourth. And then again, from there, it's just figuring out what the LCM is of the coefficients. So maybe a small area people get confused sometimes is they'll, instead of listing the least common multiple, they'll say the greatest common factor. But again, we want to know the least common multiple. Think of multiples of those numbers. When do you hit the least one? Okay. So now if we have, let's say, not rational expressions, but just expressions like this, okay, we have to find the least common multiple of those because that could be your denominator if I have a rational expression. So again, the first step here is we're going to factor each of these polynomials completely. Okay, so if I have x squared plus 7x plus 12, remember we have to find multiples of 12 that add to 7. So that would be 3 times 4. So I'd have x plus 3 and then x plus 4. And this one would be an x plus 4 times x plus 4. So that's from our factoring unit in chapter 6. Now I did give an optional homework assignment earlier in the semester on factoring. If you need to review factoring and you haven't done that optional homework, go in there and try that assignment. You know, they might have some helpful tips and just other example problems for you that you can review. And then step 2, same step here. We're going to list each factor the greatest number of times that it occurs. Well, let's look at each of these. We have an x plus 3 here. We don't have any here, but we need to list it down. So x plus 3 occurs 1 time. And then we have 2x plus 4s here. Only 1 here, but we have to list it the greatest number of times it occurs. So that's listing each factor the greatest number of times. And then from there, we can say what our LCM is. And that's just the same thing, x plus 3. You could write this all out like this. Okay, or you could say that it's x plus 3 times x plus 4 squared. Either way would work. Okay, let's do some examples here of adding and subtracting fractions with unlike denominators. So these probably won't be on your homework, but these are good practice to know how to add and subtract rational expressions. So again, the first thing we need to do is we need to find what the least common denominator is, which is also the LCM, the least common multiple. So what's the least common multiple of 6 and 7? Okay, well, one way to get a common multiple, so this is just a little trick. So we know that 6 times 7 is 42. Okay, so that's definitely going to be the least common multiple. Is it the least? Well, actually, yes, it is. So another way to do that would be to start listing out, multiples of each of these numbers. And when you get one that matches, you know, you can kind of stop. So I know none of these, or 7 doesn't go into any of these, so I have to keep going. And finally, I get to one that does. And you could do the same thing with 7. It's hard to do this while I'm talking. There we go. And I find that, oh, well, 42 is the first thing that matches. So that is the LCM. Okay. Now, this trick here of taking 6 times 7, that will always get you a common multiple, but maybe not the least common multiple. So for example, if I have 12 and 30 in the next one, we'll do that in here in a little bit, but let's just focus on 6 and 7, or sorry, the 4 over 7 plus 1 over 6. Okay, so let's now add these together. So what do? Well, this least common multiple of 42, okay, I said that I can break that kind of into like 6 times 7. So what I have to do here when I take these fractions is I have to multiply this fraction by, so in your denominator, to get that 42, I would have to multiply it by 6. And I also have to do the same thing on top, because if I multiply 4 over 7 times 6 over 6, what is 6 over 6? Well, that's just 1. So I'm multiplying 4 over 7 by 1. So technically, I'm not changing the number at all. I'm just changing what the denominator is. And then hence, I'm also changing the numerator by also multiplying it by a 6 on top. Now, the 1 over 6, what do I have to multiply that by? Well, I have to multiply it by 7 over 7. And that's because, again, I want this common denominator of 42, right, your LCM. But to get to that, I have to multiply your denominator of 6 by 7, right? And also your numerator by 7. And that's, again, because we're trying to get to this 42. Now, again, what is 7 over 7? Well, 7 over 7 is just 1 as well. So I'm not really changing 1 over 6. I'm just changing what the denominator is and also your numerator, okay? So now what we're going to do is we're going to kind of, we're going to actually multiply. So what is 4 times 6? So 4 times 6 is 24. 7 times 6 is the 42, the LCM that we want. 1 times 7 is 7. 6 times 7 is 42. So now we have a common denominator for these fractions. And we saw in section 7.3 that when I have a common denominator, I can just go ahead and add the numerator and keep that denominator. So I'm just going to simply take 24 plus 7, write it over the 42. 24 plus 7 is 31 over 42. And that is my answer there. So let's find what is the common denominator of, or what is the least common denominator for part B? So for 12 and 30. Okay, well, again, that little trick that I did before isn't really going to help us a whole lot here. It's going to give us a common denominator. I think 12 times 30 is 360. Okay. Now that is a common denominator, but it's not the least common denominator. Okay. What's the least common denominator of 12 and 30? Well, if you don't know, what I do is I start with the bigger number. And I list multiples of that until I get to one that the other number goes into. So 12 doesn't go into 30. But if I list another multiple of 30, I get 60. Does 12 go into 60? Well, yes, it does. So I can actually stop right there. And if you want to, you can verify this with your multiples of 12. That yes, eventually you are going to get to 60. So your least common denominator is 60. Remember, a common denominator could be 360, but then you'll have to simplify at the very end. If you get this LCD, you're generally not going to have to simplify. This case, you will a little bit at the end, but it's not going to be nearly as much as if you had 360 in your denominator versus 60. So let's kind of do the same idea for this one. If I have 60, okay, here is my LCD. I'm trying to make your denominator of 12 into 60. How do I make, what do I multiply 12 by to get to 60? Well, I multiply it by 5. And I also have to do the same thing on top. Whoops, it's not a plus, it's a minus. So if that doesn't really make sense to you, tend to think about that a little bit more, okay? I'm taking this number, what I'm doing, okay, is I need to multiply 5/12 to get a common denominator of 60, okay, with 11/30. I need to multiply 12 by something to get to 60, and that is 5. And I do the same thing on top as what I did on the bottom, because I know 5 over 5 is just 1, and that's not really changing 5/12 at all. It's just changing the numbers, but it's still 5/12 if I simplified it. And then 11 over 30, what do I have to multiply the 30 by to get to 60? Well, I have to multiply it by 2. Okay, so now I have that, I am going to have that common denominator of 60 when I multiply 12 times 5 and then 30 times 2. So let's go ahead and multiply the numerators. So 5 times 5 is 25 over 60 now. Minus 11 times 2 is 22 over the 60. And then I subtract here. So I'm going to skip this step. I subtract 25 minus 22 is 3. And I put it over that common denominator of 60, right? Subtract the numerators, keep your denominator. And then actually 3 over 60 in this case can be simplified a little bit more. But again, as I said earlier, if you had 360 as your common denominator, you'd have to do a lot more simplifying. But here I know that 3 goes into both 3 and 60. So I just divide top and bottom by 3 and I get 1/20th. Again, the other way that we did it, I believe a couple sections ago, is we kind of broke this up in the factors and then we canceled out. Okay, so 3 times 1 is 3, 3 times 20 is 60. I can cancel the 3's and I get the 1/20th. So either way works. So that's how you find or that's how you add and subtract fractions without a common denominator. Let's go into some rational expressions and doing those. Okay, so now for part A here, or for problem A, what is the common denominator here, or the LCD of x and x squared? Well, remember I said before that a trick here was it would be the one with the biggest power if you have the same variable. So we have an x. Well, this one is an x squared. So your LCD here is going to be x squared. So actually, when I do this, I don't have to change 5 over x squared at all because your denominator is already x squared. So when I'm making 2 over x to have a denominator of x squared, I'm going to have to multiply it by x over x. Okay. But then the 5 over x squared, I don't have to do anything with. Okay. So again, what is x over x? Well, it's just 1. Okay. So I'm not really changing 2 over x at all, besides getting a common denominator with this 5 over x squared. So let's go ahead and multiply. So 2 times x is 2x. X times x is the x squared common denominator that we want. And then I didn't do anything with 5 over x squared. And now I can add your numerator and keep the denominator. So I have 2x plus 5 over that common denominator of x squared. So that's your answer there. Now in the next one, this one can be a little bit tricky for people. That's kind of why I have this starred and then red here for part B, because these kind of look the same, right? One is x minus 1 and one is 1 minus x. Well, a couple sections ago, I think we had that trick where if I have 1 minus x and I factor out a -1, I can write this as x minus 1. Try that, okay? Distribute the -1 in here. What do you get? Well, you would get a -x plus 1, which is the same thing as 1 minus x. They have the same signs, okay? So really here, what is your LCD of this? Okay, I'm going to use the x minus 1. And to make this one to have a common denominator with the x minus 1, all I have to do is multiply top and bottom by -1. So we'll see that. So this one's kind of a special case. Okay, so if you have kind of these almost lookalikes where you just factor out a -1 in one of them, to get that, you just multiply one of them by that negative number. So I'm going to take so the first rational expression, 4 over x minus 1, stays the same. 3 over 1 minus x, I'm going to multiply top and bottom by that -1. And that's going to, again, allow me to get that common denominator of x minus 1 with this. Okay. So I have 4 over x minus 1. Let's multiply. So plus 3 times -1 is -3 over the x minus 1. Okay. Again, you can ask yourself, why is 1 minus x times -1. Why is that x minus 1? Well, that is, let's distribute this one. So 1 into -1, that's -1. Negative x into -1, that's plus x. So you can see we get the same thing, -1 plus x, or x minus 1. So in this step here, I'm sorry if I confused you. This step, okay, I was showing you that this factoring out the -1 is the same thing as 1 minus x. Okay, but really what we're doing here when we multiply it by -1, we're trying to get it to be x minus 1. Okay, not a -x plus 1. Okay, so I hope you guys can see that. Again, this is a special case, and you'll have a homework problem or two on these on this special case. So feel free to look at another example, maybe how if you practice another one, you can see how they kind of write it out. But here we would have the 4 plus the -3. And that is a, whoops, that's not a -1. 4 plus -3 is a +1. So that's 1 over x minus 1. And that is your answer there. All right, let's do a few harder ones here. So simplify the expression, write your answer in lowest terms and leave it in factored form. So we have x minus 3 over x minus 5 over x plus 7. And I want to subtract these. Okay, well, the first step, you need to find a common denominator, or you need to find the least common denominator / LCM. Well, what's the LCM in this case? Well, it's just your denominators multiplied together. So LCD here is going to be x times x plus 7. Okay, so because again, each of these are its own kind of expression. All right, so now we can take this LCD and I can multiply each denominator by what it's missing. Okay, so this x here is missing the x plus 7. So I'm going to multiply this first rational expression by x plus 7 on top and bottom. This guy, 5 over x plus 7, is missing a x. Now, sometimes people go like, well, doesn't this have an x? Well, yes, it does. But remember, x plus 7 is an expression in itself. Okay, it does not include just an x being multiplied by it. So let's demonstrate this one here. So I have x minus 3 over x. Again, I said I have to multiply that by the factor that's missing. So I have to multiply this by x plus 7 on top and bottom. And then minus 5 over x plus 7. And I multiply this one by that missing x there. Okay, so now I have x minus 3 x minus 3 times x plus 7 over x times x plus 7 minus 5x over x times x plus 7. Okay, and now what I can do is I can take this, and I'm just going to show all the steps. I'm going to write this numerator as one expression on the top. So I have x minus 3 times x plus 7 minus 5x all over x times x plus 7. So I'm not going to do anything with the denominator. Let's factor out the numerator. So let's FOIL x minus 3 times x plus 7. Well, that would be x squared plus 7x minus 3x minus 21. Okay, right? So I do x times x is x squared, x times 7 is 7x, negative 3 times x is negative 3x, negative 3 times 7 is negative 21. And then I have the minus 5x at the end. And I take that all over x times x plus 7. Let's simplify the numerator. I have an x squared in there, and then my common terms here are 7x, negative 3x, and negative 5x. When we take all of those together, that's going to give me a negative 1x, or just a negative x. So it's x squared minus that x minus 21 all over x times x plus 7. So sometimes at this point, people go, well, can you factor x squared minus x minus 21? And no, I can't, because I don't have any factors of negative 21 that are going to add to a negative 1. So I can't factor this top at all. So this is actually as far as I can go. So I just subtracted those, I just subtracted this. I found a common denominator, okay? And then I kind of, I multiplied out the numerator and simplified it, okay? And then I put it over that common denominator. And that's how that one goes. Now this one is going to be a little bit harder, okay? Let's simplify this and write our answer in lowest terms and leave it in factored form. So what's the LCD in this case? Well, in order to find the LCD, okay, I need to factor. So I haven't really had to do this necessarily yet. So I'm going to factor each denominator, and that's going to help me define what the LCD is. So x squared plus 6x plus 9, that factors into x plus 3 times x plus 3, okay? X squared minus 9, that's one of your difference of squares, remember, right? When you have a squared minus b squared, it factors into a plus b times a minus b. So this factors into x plus 3 times x minus 3. So what's your LCD? Well, your LCD is, remember, the greatest number of times that an expression or a factor occurs in these expressions or polynomials. So x plus 3 occurs twice in the first one, only once here, and then I have an x minus 3. So this whole thing, x plus 3 times x plus 3 times x minus 3, is your LCD. So when I take this guy, I'm actually going to write it in factored form. So I have 6 times x plus 3 over, or 6 over x plus 3 times x plus 3 times what factor am I missing here? I'm missing an x minus 3. Okay. And then in this guy, 5 over, again, I'm going to write the denominator, original denominator in factored form. So that x squared minus 9 as x plus 3 times x minus 3. What factor am I missing in the denominator? Well, I'm missing an x plus 3. Okay, so now what I'm going to do is I'm going to write this as one single expression. So I'm going to have 6 times x minus 3 minus, right, keep this sign, 5 times x plus 3 all over that LCD. And now from there, what I'm going to do is I'm going to multiply this out. So I'm going to distribute the 6 into the x minus 3. That gives us 6x minus 18. And then distribute 5 into x plus 3. But really, it's, remember, this sign kind of is attached to the 5. You could also write this as plus a minus 5, if that helps you. So I'm going to have negative 5 really times an x is negative 5x. And then a negative 5 times a 3 is a negative 15. All over x plus 3 times x plus 3 times x minus 3. And again, here I'm going to have to simplify. So I have 6x and minus 5x are like terms. And that just becomes an x. Negative 18 minus a 15 gives us a negative 33. And then again, that's all over your common denominator here. I might have to extend this. So this is your whole answer here. And again, some of you might have been wondering, well, why didn't he write it as x plus 3 squared times x minus 3? That is also another way that you could write that denominator. I just wanted to make sure that when I was finding the LCD that I wrote all of this out, and then when I multiplied this over here to get a common, or to have that LCD, I multiplied it by whatever factor your original denominator in each of these was missing. And now, so that's probably the hardest one. Let's do one more example. So I'm going to add 1 over r plus 1 over s and then find the reciprocal of the result. So what's the LCD here, or the LCM? Okay, well, if r and s, it's just r times s. So that one's pretty easy. So here, if I have 1 over r, what is it missing in my LCM? Well, it's missing an s. So I have to, oops, I don't add it right away. Let's go ahead here and let's just find the, or let's multiply it by the missing factor right away. So I'm going to multiply this by s over s, because that's what 1 over r is missing. In the denominator, it's missing that s. And then 1 over s is missing, whoops, I don't want to write that multiplication right there. I want to write it even with the fraction bar like I've been doing. So this one, I have to multiply it by r over r. So 1 times s is just s over rs plus r over rs. So that is equal to, I'm just going to switch these, r plus s instead of s plus r over rs. So this is actually the answer when you add 1 over r plus 1 over s. Again, I just multiplied it by the missing factor. This one was missing an s. This one was missing an r. And then I did 1 times s is s, 1 times r is r. And I wrote both of those over your common denominator, or your LCM of rs. And then I added the numerator s plus r, and I just switched those around to be r plus s by the commutative property, right? You can just switch those around. And then what is your reciprocal of this? Okay, well, the reciprocal is always just the flip. So to find the reciprocal, all I have to do is flip-flop those. So rs is going to go on the top, r plus s goes on the bottom. Okay, this is your answer. Okay, this is your reciprocal. And that is all for section 7.4. Okay, we're going to continue on here with some of this next time in 7.5. And for that section, I will see you all next time. So have a good one. We'll see you for 7.5.